Okay, so now we want to look at MOSFET switching when we're doing a P-type MOSFET instead of an N-type MOSFET. So we're going to take and switch around and learn how to do the P-type MOSFET. So the P-type MOSFETs are going to be fairly similar, except for now we need our gate to be less than our source. So what we do is we take this transistor, so this is now the P-type, and we've taken the source, which has the arrows, and we've taken our transistor and flipped it upside down. So we tied our source to our 15-volt power supply, so the source doesn't change. So then we just have to control the gate, and then we're going to take and put our load on the drain just like we did before. But what ends up happening now is now my resistor is connected to ground rather than being connected up to the 15-volt power supply. So these are called high side loads and low side loads. Okay, so we're going to come in here. Here's my microcontroller, and we run this, and this is switching from the 0 to 3.3 volts. And then I look right here, and I just get 15 volts. So my MOSFET is, well, now this voltage is tied up to this voltage, right? So that's 15 volts. So this one is in triode. So it has a large gate to source voltage, so this is 3 volts and this point is 15 volts. So you see my gate to source voltage is changing from 15 to like 12. So it's always in triode. I can never get it to go off. So if I look at what is the threshold on this one, the threshold is, let's see, where is it? Minus 2.8 volts. So in order to put this into cutoff, this voltage right here has to be 2.8 volts away from the 15. So this has to go up to, what is that, like 12, 13 volts rather than the 3.3. So in order to do this, I'm going to use a level shifter just like I did before. And I can use an N-type level shifter in this case because this is tied down to ground. So I'm going to come in here and grab an NMOS, and we're going to grab that same small NMOS, that 2N7002. Okay, so now we're going to do just like we did before. And we're going to connect this one up to our power supply. We need to put in a resistor so the voltage has something to drop across. And then we take our drain and tie that up to our source. And then we have a 1 kilo ohm resistor. So when we do this, you see here is my input 0 to 3 volts. The output here is changing from 0 to 15 volts. And now when this is at 15 volts, this is going to turn off. And so then I get my switching right here. Okay, and you see that when this goes up, that goes up and everything works out. So this is switching with an N-type MOSFET. But now we want to look at it in a little more detail. So there was let's pull this over. So I was going through something and saw this question come across, okay? So it says that he's building a circuit that looks like this. Now he's using, or this person is using, a BJTs instead of MOSFETs, but it's the same thing. And so what we see here is that this part right here is the level shifter, and this is his switching structure. Okay, so let's replicate what he's doing here and see what his problem is. And what he said is that the rising edge takes 38 nanoseconds to switch, but the falling edge takes 3.5 microseconds. So this is like, almost like 2 orders of magnitude slower. So we need to figure out why that is. So let's go back and look at our case and see if it's similar. So here's our level shifter, and we should do things about the same. So we're going to look at these edges. We're going to do that by just zooming in a little bit. So we're just going to make this switch a little bit faster. Okay, so we're going to make this switch faster. And what we see is that ours is the same way. So I get really fast switching here, but I get a delay and really slow switching on this side. So obviously we have the same problem that that other person ran into. So we can solve his problem and solve our problem to figure out what are we going to do to get this to work out. So we have to understand what's going on. So let's look at what? So we need to look at this gate to source. So what we see here is this gate to source is going really fast and this gate to source is going really slow. So what we have to do is we have to figure out what is the RC time constant of the switching. So let's start with this one here. So when my voltage goes up, so when this voltage goes up, it takes this transistor and moves it up into triode. When this gets moved up into triode, this point becomes a short circuit. So the Thevenin resistance seen by the capacitor that's right from this gate to drain, when we're trying, or this gate to source, when we're trying to drain these capacitors, this is basically being shorted, and so my gate is tied to ground, and that's a low resistance, and so it's going to operate really fast. Now, when this one goes down, this becomes an open circuit. So that would be like removing this. So when this one goes into cutoff, this becomes an open circuit. Well, now what is my gate tied to? Well, my gate is tied through this resistor up here. So it's going to have, this is my resistor. So rather than almost zero, really small resistance, we have a really large resistance. Well, so then all that I have to do is change this into like 10 ohms. So if I change that into 10 ohms, then the problem is, you see, this is starting to drive lots and lots of power. This is consuming watts of power, and then this is going to break, right? So this is going to make it switch faster. Well, except for it didn't even get it to work all the way because I did get it down far enough. So I went too far. Okay, so that kind of works. But again, you see I'm consuming too much power. Even at this point, I'm doing hundreds of milliwatts that I don't really need, and I get these big spikes. And so this works, but it doesn't really work very well. So what we need to do is we need to have something that switches down, and then also something that switches up, so that we have another switch here. So what we can do, there's lots of different options to do this, okay? One is I don't really want this to tie to a resistor. I would like to put another switch right here. So if I came in here and put in another switch, now this other switch, it's the opposite like this, so I want to tie it up. So I would want to put in a PMOS, and then we're going to rotate it. And so it's going to be tied like this. So you see now when this one switches, so these are basically acting like an inverter. So this point is either tied up here through that one, or it's tied down here. So these are going to be switching at different times. So if this one's on, this one's off, and vice versa. So we just need a small transistor here. So again, we want to do something that can handle something that's nice. So the small transistors tend to have these large R-ons. So let's just grab this one. Okay, so now we have this. And then these should switch at the different times. But the problem is this is 3.3 volts, so it's going to switch this one. This one isn't going to ever switch off. Okay, so what we need to do is this one has a threshold of 1.3 volts. So that means that the voltage at this gate needs to be 1.3 volts from the 15. So what am I going to need to do? Well, this can't be 0 to 3 volts. This needs to be, we are going to need another level shifter in there. So now we're going to take this, and the goal here is this one is just shifting up and down. Okay, so let's see how this works. So this voltage here is 0 to 3. This voltage here is 0 to 16. And so then what's going to happen is when we're at the 16, this one is on, this one is off. When we're down at the 0, then this one will be on and this one will be off. So they're basically just going to switch back and forth. And it got a little faster, but it's still a little bit slow on this end because we have the same issue. And some of the other problems we have to watch for is that the switching is slow between these two, right? So if I look at these gate to sources, that eventually you're going to have, there's going to be a small period where they're both on. And then if they're both on, I've taken this 15 volt and if these are both as short, I've created this spike. So if they're both on, I basically shorted my power supply and I get way too much current. So this works, but I have to really delay these. So what we can do is we're going to have one of these level shifters to this one and one of these level shifters to the other one, and then I'm getting more and more transistors to get all this to work, okay? So there's other ways to do it. So this stuff here that we're doing here is all called a gate driver. So we're basically creating circuitry to drive the gate of the transistor, okay? So they actually just make little gate driver circuits that we can play around with. So let's grab a gate driver circuit. I went and looked up one that is included in LT-Spice. So if we go over here, we have all these other components, and so here are power products. So we're going to grab an LTC 1693. Okay, so this has a little chip, 1693. So we're going to have to come up here and do LTC 1693 to see what these look like. So this is a high-speed single or dual N-channel MOSFET driver, okay? So we've got these big long circuits. Let's find out what the pin structures are. Okay, here are the pins, okay? So we have output pins, grounds, input pins, okay? So if I come back over to LT-Spice, VCC, oh, well, that's my power. So I'm just going to tie this up to here. I have the ground, so I'm just going to tie this point to ground. I have the input. So this becomes my input, and then I'm going to tie this point to my output, okay? And we got this phase shift. Well, let's go look and see what that was. So here's phase. Okay, so the output polarity selection. Connect this pin to VCC or leave it float for non-inverting operation, and ground the pin for inverting operation. So I can either tie it to high if I want my, so this can either be inverting or non-inverting. Well, right now, let's just tie it up here. Okay, so then when I run this, you see this is going from 0 to 3. This point's going from 0 to 15. And now you look that both of these edges are switching really fast. And so now, since this point here is pulling all the way up and all the way to down, it's providing the driving for this MOSFET in both states. So it's going to drive up and drive down and cause this to switch fast. And so now we can kind of see on this side here. Let's look and see what that switching time is. You see this is 80 nanoseconds for switching time. That doesn't seem too bad. And then we zoom in here. And this one here is 240 nanoseconds, but it's still, that's just a little bit, a factor of 4. And then they make fancier drive circuits for high side and low side type drivers. But you can kind of see that this was way better than us doing it with the discrete transistors. And so this kind of explains using what's called a gate driver as a level shifter, because it created the level shifting as well, and it also helped it with the switching. And then we also learned about how to do these p-type transistor switching. And that is the end of this video.